So far, all of our variables have been static variables. With static variables, the declaration allocates space in memory, and then that space allocation is fixed for the entire duration of the program's execution time. Dynamic variables, on the other hand, with dynamic variables, they are created and possibly also deleted during execution time. So while your program is actually running, you can say, oops, I need another location. You can dynamically allocate a new variable. So dynamic memory allocation is when memory is allocated dynamically, again, while the program is executing. The functions that we use are both from the standard lib header file. Malloc, which stands for memory allocation, receives one argument, which is the number of bytes in memory to allocate, and then it dynamically allocates that much space, and it returns a void pointer to that space. So it returns a pointer of the type void. Now that's to dynamically allocate memory. The function free frees up the space that's pointed to by a pointer. So you can dynamically allocate memory while the program is executing, and you can also free up memory. So again, the malloc function allocates a certain number of bytes. So for example, if I said malloc 8, that's going to allocate 8 bytes of memory. Now generally what we want to do is we want to allocate enough space in memory to store a particular type. The size of function will tell us how many bytes we need for that. So the size of function returns the number of bytes necessary for a particular type. So for example, size of int is going to return the number of bytes that I need to store an integer value. So if I say malloc size of int, that's going to dynamically allocate enough space in memory in which I can store an integer. So a little more on malloc. The malloc function returns two possible things. A null pointer if the space cannot be allocated, so that's a pointer whose value is null. Or if it can allocate the space in memory, it returns the address of the memory that has been allocated as a pointer to the type void. Generally, what we want is the pointer to be of the type of the memory that was allocated. So we can use the cast operator to change from void to that type. So altogether, when we have size of int, that's the number of bytes we need for an integer, malloc size of int is going to dynamically allocate enough space in memory for an integer and return it as a void pointer, but then we use int star as the cast operator to change the pointer that we get from malloc from void to be an integer pointer. So since we're allocating enough space to store an integer, we want an integer pointer to point to it. So here's a simple program that has some dynamic memory allocation. So first of all, I'm including the standard I/O and the standard lib header files. I have one variable declaration. I'm declaring a pointer variable IPTR. So the variable declaration is going to allocate the space in memory for that pointer. So it's declared to be the type int star, which means that it can point to a location in which an integer value is stored. So again, this int star malloc size of int, that's going to dynamically allocate. So notice this is while the program is actually executing. Now we're going to say, okay, we're going to allocate a new location with enough space in memory for an integer. We're going to make that into the type int star and store the address in IPTR. So we dynamically allocate this new location, and IPTR points to that location. Now remember that the value of IPTR is the address of the location. Star IPTR, using the dereferencing operator, is the value in that location. So we can store a value in that location using an assignment statement. So star IPTR gets the value of 5, for example, does that. And then we might print the value is, and the value of star IPTR, which again is the value in the location pointed to by IPTR, which is 5. So notice that now with dynamic memory allocation, the only way we have of getting to this location is by following this pointer. So before we had a direct reference and an indirect reference. Now we only have the indirect reference. So with dynamic memory allocation, we just have the the indirect reference from this pointer variable. Now free IPTR is going to free up the space pointed to by IPTR. So basically it frees up that space. We still have our pointer variable, but it's not pointing to anything anymore. So malloc dynamically allocates free will free up the space. All right, now let's up the ante a little bit. Let's use call by reference with a pointer variable. So what we're going to end up with is a pointer to a pointer. So rather than initializing the value in the main function, we're going to have another function that will accomplish that. So let's take a look from main. Again, I'm declaring a pointer variable IPTR. So that declares the variable, which means we allocate space and memory for this pointer variable to be the type int star, so it can point to an integer location. Okay, now I'm calling my function init, and I wanted to initialize my pointer variable, so I'm going to pass the address of the pointer variable. So I'm passing the address of something of the type int star, and that's going to correspond to a pointer to something of the type int star. So when this function call is encountered, that sends control to the function. The first thing that happens in the function is that we declare the IP. So again, that's a pointer to a pointer, and what we're doing is passing the address of IPTR to be the value of IP. So IP is now pointing to that location. So again, we're passing the address of IPTR to be the value of this, which means it points to that location. Okay, now, the value of IP is the address of IPTR. Star IP is the value in that location. So what I'm going to do now is to dynamically allocate a new location large enough to store an integer and return the address as an integer pointer. And we're going to store that in star IP. So again, star IP is the value in the location pointed to by IP. So now it points to this new location. So IP is a pointer to a pointer. So now, if we want to put a value in this location, we have to follow the two pointers. So the only way we have of getting here is by following the pointer from IP, because all we have in our function is IP. We don't have IPTR. Following that pointer to this location. So in other words, using the dereferencing operator twice. Star IP is the value in this location. Star IP is the value in this location. And we want to make that 5. Now that's the end of the function. The function stops executing, so that sends control back up here to main. So when control goes to main, our parameter here, IP, goes away, but now we have actually initialized IPTR. It points to this new location, and now when we print the value of star IPTR, it's going to be 5. And again, if we free, then that's going to free up the space that this pointed to. Okay, so that's call by reference with a pointer. So we ended up with a pointer to a pointer. So that's looking a little bit gnarly. Okay, so in order to make this look a little bit nicer, what we can do is we can create a type definition for a pointer. So I'm going to use typedef to rename int star as int pointer, intptr. I'm going to say that int pointer. So that I'm going to use that in my function header and in my function prototype. So int pointer is the same thing as int star. So now I can use that type name in my declaration. So this is going to do the same thing as before. It's just going to look a little bit nicer. So we have IPTR, which is the type int pointer, which is a pointer to an integer location. We're going to pass the address of that to a pointer parameter. So again, now it looks a little bit more natural, but it's still int star star. So when we call the function, we get IP, and IP points to IPTR. So again, we're passing the address of IPTR to be the value of IP. Now star IP, the value in the location pointed to by IP, is going to store the address of a new location that I allocate here. And then again, star IP gets the value of 5, so we can't get away from using the dereferencing operator twice. And then we get back to main, IP goes away, and we have the value of star IPTR, which is 5. So it does exactly the same thing as before, only now the function prototype and the function header, they look a little bit more like they did before, so we don't have star everywhere. But again, we do still have to use the dereferencing operator twice to get to the actual value. So that's how we can use the call by reference method to pass a pointer variable to be initialized within a function.